This is session 3, tutorial 3 for Python. Okay. Welcome again. All right, so today I'll begin by asking how things went last week. So last week I assigned more advanced problems for Python. So we'll take some time to go over them, and I would really love to hear from you on how things went. So does anybody want to start, or shall I go through them one by one?
I thought it went pretty well. It was really time-consuming sometimes just trying to find the right code to use in it. But once that, once that was down, it was really.
Okay, so the main thing was just learning where to look for what you needed.
Right.
Okay. Anybody else?
Same thing here.
Oh, okay. I think that was Rick and Debbie in that order, right?
Yeah.
Okay. All right. So let's go through them and let's see how we could find what we need. Or if I can help you with that. So the first one, was basically to find the square root, and I'm going to emphasize the use of NumPy. I know that basic Python also has some of the same functionality, and NumPy duplicates them. But I would urge you to sort of start migrating to numerical Python, even when you have a duplicate function available. And the reason is pretty simple. NumPy is just got a lot more to offer, and it can work with NumPy arrays, and which you're going to find a lot more useful in the long run when you're trying to do numerical calculations. Okay. All right. So the solutions are up. So you've already seen these. Let me step through them. I, of course, want to start by importing my NumPy library. And once I've done that, np.squareroot gets me the answer that I'm looking for. So let me ask you this: was it the syntax np.squareroot, or was it the fact that you didn't know it was called sqrt? And then how did you find it in the end that it was sqrt?
Well, I took another look at what you did last week, what you posted, and a lot of what we had to do was in that.
Okay.
Yeah.
Was it the links to the documentation, or was the command actually in there?
The command was in there for a couple of the assignments with the problem.
Okay. Just out of curiosity, let me see how quickly I can find this. If I say Python, NumPy, square root. Okay, so it shows up here as well. So I recommend using Google, if nothing else. Anybody else like to share how quickly or easily or in the end what worked when you were looking for this?
Well, the links also work that you have that too.
Okay.
For some of the later problems, we found a cheat sheet for Python. Cheat sheets.org.
Okay. Well, I mean, if you find them useful, do you want to share it with the rest of the participants, and I can link it here as well. Okay. So yeah, the help is essentially interspersed, and then there's Google. And it's also a matter of becoming used to it. This is something that I've learned in programming, comes up over and over. Once you're using the same things over and over, you don't need to look them up. But oddly enough, once you stop using it, within a matter of weeks for me, sometimes I have forgotten what it is, so I usually go back to try and figure out how I was doing it. So let me take this moment to tell you a little bit more about how I learned programming, how I learned new languages, and also how a lot of my colleagues do this. So this is, I mean, I can safely say that this is fairly common practice, at least among the scientists who are not programmers by profession. And in fact, you guys are also more or less in the same category. So I find it incredibly useful to have sample scripts. Comment them and save them. You can either find examples online, or you can find, your old scripts, but you save it, and then the scripts themselves become the reference. And you can, if you can remember, when you needed to use that particular function, you can go back and search for that script, and that quite often is how you remember the syntax or how to call it. Okay? So finding other scripts, and when I'm learning a new language, I tend to look for scripts that do something similar to what I plan to do, and then learn by just reviewing the code itself. That does require certain knowledge about programming concepts, so you can transfer that knowledge from one to another. When you're learning a new language, it's helpful to also see how others do this. So this script that is now the solution to the exercise should be something that you can also use as a documentation. Okay, so I won't belabor that. Let's move on. So if you tried adding two strings, you discovered, as I will highlight here, that it simply concatenates the strings. This is incredibly useful when you're trying to build print statement or useful statements. Let me explain. For example, A is equal to some value 10, and you want to say that the value of A is whatever it is. You can use concatenation in this case. But first, of course, you have to translate A to a string, and then you can have these useful print statements. That's just one simple example, but you can see the utility of this mode of working with the strings. Next, we had the minimum and the maximum. That was just to get you to think about how to create or get used to the arange function in NumPy. Actually, it exists in Python as well. And to use some of the other functions. You're working with numerical data, so here it is. On the bottom right, I just executed the code, and it created the minimum is 0, the maximum is 98. So does anybody want to volunteer why it did not go to 100?
It starts at 0, right? First.
Yeah.
Right.
But it didn't go to 100 for something that's kind of peculiar to Python. Now, I didn't tell it to the number of times it goes. I just gave it a starting and an ending, right? If it start at 0, end at 100, count by 2. So it should go 0, 2, so on. But it stopped at 98.
You'd have to type in 101.
Or 1 or 2 in this case, because we're taking 2. Yes, it's
okay.
Up to, but not including. That's how you should look at it. So 0 up to 100, but not including 100. And the increment before 100 would have been 98, because we're taking steps of 2. Okay. So feel free to interrupt me. Otherwise, I'm just going to sort of plow on ahead with my talking. All right. The next example is something similar. We're just doing it with floating points. I won't belabor it too much. np.sum is another nice utility. And then, of course, instead of populating an array with a value from starting to end with increments, you can just populate it with 0. That's far more common, and so we use np.zeros for that. And in this case, A is nothing but a set of zeros, and the length of A is command, and this is how you can find it. Okay, Margarita, you have a question? Oops. Hello?
I think your sound is cutting out on that for me.
Yeah, I say the same thing. I am having a lot of trouble with the audio, and I don't know whether to make your window bigger, please.
Okay.
The audio is very bad this time. I don't know why.
Can you, is it the audio line? That's what you're saying. Okay, I can see if I can do better here. Let me zoom this.
Yeah, the audio gets worse when you're typing.
Yeah, exactly.
Okay, probably because I'm going through the internet lines. That's my guess. Okay.
Maybe because typing, I cannot hear you anything at all.
Okay. All right, so I will try and do this without typing. But presumably you have run through these problems. So let me ask you this question. Were any of these problems, are there any particular questions, apart from finding out what it was? Was there anything in the in how you construct the solution that was difficult, or do you want to share any information about that, or have a question?
At this moment, maybe not, but I have a problem with your window. It is very small too, so.
Yeah, I just tried increasing the font size, and I realized that I don't know how to do it in Spider. Okay, I will skip that part then, and we can move on to today's presentation instead in more detail.
I have a question.
Yeah.
Before. I had trouble with the last question. I think it was the last one where you asked us to have the last 5 rows turn to 20. I could only do it single row, but I see how you did it. The solution. So that's, where would I find something like that if I needed to get the answer? Would it be Stack Overflow?
Okay. Yeah, you can ask the question. You can simply type the question into Google, and that works. But this is one of those very basic Python indexes, and your first or index access, and your first sort of learning point here should be me. So if it's not explicitly clear in the lecture material or the slides, then I should modify the slides. But I should give you the very basics of how to select, or that should be part of the slide. So I would say in this case that material should be in the slides, and if it's not, then yeah. That would be, but then after that, you can ask that question or go to the links on the documentation for Python. The problem with documentation on Python, and I try to be good about it by not forcing too many links onto you, is that there is a lot of documentation online. And so I think that in some ways that makes the problem worse, because you may not be able to find what you're looking for very easily. The other thing that I can recommend is, because that, with the question that you asked for, is sort of part of the core knowledge about Python, is to get a book on Python. And I can add a couple of recommendations if there are interest in that. There's not, some inexpensive books out there that cover the very basics, just to get you going.
Okay, cool.
Okay. So today's topic, just discussing last week, and moving on to some other useful Python commands that don't really fit into any of the slots that I've built or the way I've organized these lectures. Then the main thing for today is to introduce the concept of how to control the flow of commands in your program. Remember, a script or a program is nothing more than a set of instructions for the computer. And so far what you've seen is sort of this linear progression, instruction 1, instruction 2, instruction 3, instruction 4. You can do a lot more, and in fact, the power of the programming really comes in when you can control which set of instructions are executed when, and if you need to repeat any instructions, how you would do it. And so that's the concept of these if-then blocks and loops. Okay. And so today, mostly we'll talk about that, and then I will start the conversation about how you read and write files and data in Python. Okay, but most of that will be covered next time. Okay, so this question? Okay, how's the audio, by the way, now? I've stopped typing.
Yes, better. Yeah, much better.
Okay. All right. So first, let me introduce you to the concept of printing. You saw me use print, and then I showed you a neat trick where you can concatenate strings to make basically program an output. You can mix and match things. So far that's been pretty easy. We're used to it. There's a second way of printing, and that's calling a low-level library. When I say low-level, usually means it's very intrinsic or basic to the core Python language itself. Okay, so system routines, SYS for short, are some of those low-level routines that give you some very powerful functionality. Instead of typing print and then whatever you're trying to print, you can also write it to what's considered the standard out. Okay, so after you've imported sys, and sys, if you don't tell it import as, it will just import it as sys itself. So sys.standardout.write. Okay, so sys is a library, just like NumPy. Okay, NumPy is too long, so we abbreviate it as NP. Sys, we leave it as sys. So sys.standardout gives you access to what is called the standard output. Okay, standard output. The concept of standard output is basically when you print things, when you do anything, where does that go? Okay. When you dial up Python or any programming language, the standard output is almost always defined as your speed. And nowadays, that didn't used to be the case. You could have a line printer, concept from decades ago, where the standard output could go to. But the standard output device is what's connected to sys.standardout. And then you can get a hold of it and manipulate it to do whatever you want to do with it. And so sys.standardout.write says, okay, grab standard out and write to it. Okay. Again, these libraries are written, these functions are written by humans for humans. The computer could care less. All it knows is that the right translates to instructions that tell it to print. So it's kind of like a dog. It doesn't care about what you're saying. It just knows a few commands, and that's what it pays attention to. Okay, so why would you want to use that over print? Most of the time you don't. It's only when you want to get into some fancy way of controlling, say, whether or not the carriage return is printed. So the difference between some text and some text with a \n is that after it prints some text, the cursor remains next to the T, the last T printed. Whereas in the next line, the /n tells it that you want to hit carriage return, so the cursor puts a return symbol and then moves to the next line. Okay. You may or may not wish to use it. I'm introducing the concept so you have an idea of sort of the power of Python. And you can explore sys on your own as well. Most of the time we'll stick with print. Okay, now the next step we take with print, though, is to control how the formatting works. Okay, so strings are strings and numbers are numbers, but you can print the numbers with various decimal spaces or exponentials or however you want, and that's formatted output. Okay, and again, Python is incredibly versatile and incredibly, it has a lot of options in it. I'm going to, and this is a theme that's going to continue back and forth, I'm going to stick to one path, which is, in my opinion, the simpler path, and introduce that to you. Okay, but always keep in mind that you can do the same thing, probably about 20 times in different ways in Python. And your own style will largely dictate what you prefer. So this type of formatted printing uses the quotation marks, okay, and the percent symbols. So let me walk you through it. I dare not type it, but you can type it maybe on your own, even as we're going through this. So it's pretty simple. You have some whatever you want to print, usually, and it's in strings here, okay? And then you see a few special characters. There's a percent signs that come in, okay? And every time there's a percent sign, Python starts listening for formatting instructions, okay? And here are two formatting instructions. After the quotation is finished, okay, Python is expecting another percent sign, and that tells it in order which argument belongs with each one of these percent signs, okay? And when the printed statement happens, okay, these percent and then the arguments next to them are replaced by the values that are at the very end here, okay, formatted according to the instruction given in the percent sign. So in this case, what it's going to do is to take 2048 and 2048, and the first thing it's going to do, because Python is, in its heart, a calculator in a way, is going to add these two numbers together and come up with 4096, and then it's going to print it and say result equals 4096. The 4 here means use 4 spaces to print this result, and I tells it that it's an integer value. Okay. And then the next one is 2.2, and that takes up 1 spot for 2, 1 spot for the point, 1 spot for the 2, so 3.1 would print it exactly as 2.2. And the little f means it's a floating point. Okay? That's the basic construct. More generically, if I were to write it, it would be something like this. So it begins with a percent. Okay? So Python has to know within that string that you have, you're asking it to print, somewhere in the string, okay, it's going to just start printing it, but it's only when it comes to the percent when it really knows that this is now formatted output. Okay, so that's our escape character or the pointer. Width is how many characters you need, and then a dot, and then the digits after the decimal, and that really only applies to, you would think that this really only applies to floating points, but in fact it's also useful with integers, and I'll show you why in a bit. And then one of I, F, and S. Of course, I'm simplifying it, and I will unsimplify it in just a minute. But I for integers, float, F for float, and S for strings. Okay. And so here are some examples. %9.2 F. 9 take 9 spaces. Okay, that includes the decimal. That also includes the plus and the minus symbol. Okay, so it's exactly 9 spots. Okay, and you have to be you have to make sure that you give it enough room. Okay, because the dot and the minus, sometimes those are the two most common characters that are forgotten, especially in floating points. And then an F. Okay. Now, if the number is smaller, it doesn't need all 9 spaces. It's okay. It will just ignore the rest, depending on how you're trying to print it, or it will just fill it up with spaces, empty spaces. But if it's too big, then it's going to replace with whatever you're trying to print with asterisks. That's Python's symbol, a way of telling you that you sort of went over your limit. So if your number took up not 9, but 12 spots, okay, then you won't see any numbers. You'll just see a bunch of asterisks. You can also combat this if you aren't sure what your numbers are going to look like by simply saying %F. No arguments given, no bits digits, and Python will choose some way of representing that number. And it's usually fairly bad. For example, if you're trying to print 12.2, you might get 12.199987246, an ungodly number of digits after the decimal, none of which are significant. So it's, when you ask it to do some printing work like that, you should really only use it when you're completely unsure what your result would be. Again, with integers, if in the next example, 6i, if I specify an integer that only takes up 2 spots, the rest of them would be blank. Okay. An alternative would be to use 6.6i. Okay. Now the 0.6, okay, we've said that it's the digits after decimal for floaters. But for integers, it treats it very funny. It treats it as filling everything up before if there's extra room by zeros. So if you're trying to print the number 2, it would be 5 zeros and then the number 2 with the 6.6i. Okay. And that's useful quite often if you want to stick to 6-digit formats for any reason. And that's, in fact, it's used in astronomy catalogs all the time. Okay, and then the last one is the string. If you just give it a 20 and then an S, then the strings are always right justified. If you instead want the string to be left justified, you need to put a minus in front of it. Okay. So here's the full list. Like I said, I, F, and S are the 3 most basic and the ones that I expect you to use for most of what we're learning here. The full list actually allows you to print all sorts of numbers. And even, the other one that you're probably going to use are the exponentials or the G construct, which is a little bit better than exponential. If the number is small enough that it doesn't need an exponential, it drops to an F format. But if it gets too large, it automatically switches to the exponential format. Okay. All right. Any questions? the last one is kind of interesting. If you do want to print a percent symbol, what do? Well, you just precede it with a percent. So a percent means that, if you're trying to say that, the blue stars are 20% of my sample, you would be scratching your head and so either write out the word percent or you can get percent. Okay, I assume no questions, so move on. Other useful command is range. You got introduced to it in np.arange. Basic Python also gives you a range. And quite often we'll use that, especially in loops. Okay, another command is called pass, P-A-S-S. And that just basically, it's a filler, and it tells Python nothing is asked of you. You may skip this and treat it as a filler. It's not the same thing as a comment. A comment is ignored by Python, and pass is quite often ignored, or is ignored by Python in almost the same way. But pass is there for basically programming style. And this will become more clear to you when you see more of the programs written. So, for example, if you have a block of instructions that have to be executed by when a certain condition was right, okay, is part of your if then else block, then you could put those instructions in. But if you had nothing else to execute besides that, but you wanted to keep the else construct, then you might want to use something like pass. It's an actual instruction, and Python would come to it and would do nothing. If you put a comment there, you may actually get an error. Okay. So it might become more clear when I get to then, which is the next topic. All right. So the whole point of if then else is to control the flow of the program. Okay. You set the conditions, and you can set as many conditions as you like, and you can set the conditions to be whatever is a valid condition in Python, and then execute blocks of code based on whether the condition is met or met differently or otherwise. So examples would be only compute the logarithm if the value is positive. Okay, there's no such thing as a negative logarithm of a negative value, so that makes sense. Or something more mundane, or maybe has meaning for your program. If the user is Peggy, print the state is Illinois. These are just things that I came up with without any context of where they came from. But if you have things like, the last example comes up quite often. If you're trying to band merge two different parametry files, and say you have a 2MAS catalog and a WISE catalog, and you find more than one matches, you want to catch that. So you would say things like, if more than one star is matched, what to do next? And what's your solution? Either print out both, take one or the other. How would you take, or which one would you take? So here's the sort of things that you would enclose in your if-then blocks. So before you get to the if-then blocks, you would have to understand how the Boolean operators work in Python. The Boolean is the condition that always has an answer yes or no. And you can combine a set of Boolean equations that way. Now, in Python, if you use the word x equals y, it simply says x is equal to y. Whatever value is in y now belongs to x as well. Okay? Just like when I say a equals 10, you set the value of a to 10. There you would set the value of x to y. So you can't have if x equals y. Okay? If you do that, you would get x equal to y. And then it wouldn't know what to make of that. And it would interpret the x equal y as a yes or a no statement, not because x is equal to y, but whatever the result of x equals y operation is. I won't go into detail for that. The way you would test equality is with a double quote in an if-then block. So if what you're trying to say is x, if x is the same, has the same value as y, then you would say x double equal to sign y. Same with, and then the less than and the greater than are obvious. If you want to say x is not equal to y, you use the exclamation point is equal to, and if it's less than or equal to, greater than or equal to. Okay. Again, these are part of the core Python logic, and it's something that you learn, and then you can either print it out until you get used to it enough that you don't need to remember it. Okay. Most Booleans are constructed that way, but like I said, you can combine them. So you can say things like, if x is less than a particular value and it's greater than certain other values. So we'll come to that a little bit later. Okay. So the crazy examples that I came up with in this slide, let's see what they look like in Python construct. So an if block obviously starts with an if, okay? So you type in if value is greater than 0.0, okay? Then do log value equals np.alog10, which takes log of the value. Okay. What you should notice are two things here. First, at the end of your if statement, if value greater than 0, that was not sufficient. You have to actually put in colon. Okay? If you don't put in colon, then Python wouldn't know where the if block, if statement ends. Okay? Here, it's pretty simple, but when it gets complicated, Python will get confused as to where your exact ending is. So use the colon. So if value is greater than 0.0 colon, that's your full if state. And then the next thing you notice is that the subsequent line looks like it's pushed out with a tab or indented, and that is a correct observation. Okay, everything that you indent after the if block belongs with that if block. So if value is greater than 0, you don't have to just take the log of the value. You can execute as many commands as you like. Okay, like in the third example, which we'll get to. And that's it. And once you're done with the if statement, you can unindent back to the same level as if, and the program will continue. And in this case, I've used a pass statement to indicate that the if block has ended. This is purely programming style. You don't need to put the pass. It's not expecting it. The only thing Python is expecting is that the indentation has stopped. So it will stop associating further commands with the if block. If I were to replace the pass with a print statement, then it will do the if block, okay, whatever is indented, if the condition is met, and then move on to the print block. You will not need the pass state. Okay, and the next one, if user equal Peggy, print the state of Illinois. And then the last one, if number of stars that are matched, presumably the variable n matched is being used to store how many stars are match your result. If it's greater than or equal to 2, then execute 3 statements in this case. First, you compute the delta magnitude, okay, between the whatever your current 2-match star is, the predicted K magnitude list might be. Then you search to see which one of those is the minimum, and then you put your IRS match to that particular ID. Okay. So the context of the full code is missing here. The point that you should really be paying attention to is how to include multiple statements in an if block. Not so much the rest of it. All right. If the condition is not met, you can execute something else. And appropriately enough, that's called else. Okay. So I'm going to stop here. And maybe next time I can also go a little bit over if else. Okay. If value is greater than 0, do this. Otherwise, do something else. You can include another construct where it said if value is 1, do this. Else if value is 2, do this. Else if value is 3, do that. And else, do something else. Okay? All together. Any questions about the if block? Okay. All right. Pretty simple. Let's move on to loops now. And loops are used to repeat calculations. Just with the if block, the indentation is extremely important here. And Python will associate each of the loops or the executions that belong to a loop by looking at the indentation level. Okay. So for loops are the most basic loops. They start with FOR, the word for, obviously, and then a set of instructions that tell it how to do the iterations. So let's go over the detail here. So for the statement 4 is followed by a variable, and it's quite common to use the word I. Okay, that I think comes from mathematical expressions. When you have vectors and you want to denote a particular value, you would say, capital V or A, whatever the vector symbol is, and a subscript I. Okay, or it can stand for iterator. Whatever it is, I has become the most popular, as far as I know, variable name to use when you're doing these loops. That said, you have to be careful. When you nest loops, nesting means you can have 2 loops inside, you can have one outer loop and then one inner loop if you wanted to. Then you can't use the same variable. So in this case, I will go from the value 0, 1, 2, 3, 4 in turn. So first it will start off with 0, then 1, then 2, then 3, then 4. So the construct is my variable in, and the in is a Python command that is followed by what Python is expecting is a range of values. Okay, so for I in these range of values, again, you stop the syntax by putting a colon. Okay, so, and then after that, indentation. The first thing you do here is print I. Then you compute the square of I and set that equal to a variable named SQI. Okay, and then we have a print statement that prints I using 2 spots, which is enough, and I squared is also enough. 16 is the most we're going to get out of it. Okay, so and at the end of that, you unindent, and the next execution after the 4 blocks takes over. If you wanted to, you could put a pass statement at the same level as the last print statement beforehand, just to specify that the loop block is ended. Again, if you don't like to use indentation as your visual for where my for loop is ended, you actually want a command, then use pass. Okay. So always remember, you're going to have to end it with a colon for both the if and the end. Okay. You can execute as many things as you like. Within a for loop, you can nest an if loop. Within an if loop, you can nest a for loop. At each level of nesting, the indentation would get pushed further in. We'll see if I have an example. Yes. So for I in range 20, so range 20, this is now you could either use numerical Python or just the Python range 20, you'll go from 0 to 19, and I will increment from 0 to 19. Okay. And then you have a second variable named j, which is going to go from 0 to 11. You do a bunch of statements, and notice the indentation changes. Okay. You double indent. Every time you nest, you're going to be indenting further and further. So if you have 6 loops or 6 if-then loop combination nesting, you would be pushed pretty far out. But you have to pay attention to it, unfortunately. You have to keep those indentations because unlike other programming languages, Python really does not understand where loops end without the indentation. Okay, so any questions on this? So what you're looking at here is a compact way also of specifying the range from 0 to 19. Okay, you could write it out. So here, for I and 0, 1, 2, 3, 4, you could write it out as up to 19, but the range obviously is a lot easier to use. And in reality, you may be limited by a certain set of values, and that you define before you get to the for loop in the program. Okay. Now the power of Python over C and Fortran in particular is that because it's a higher level scripting language, the loops can go over any value, any ranges. So I could say, for name in, and then a series of names. This happens to be my NITARP team from last year, Carolyn, Melissa, and Peggy. I can say print hello, and then in a % formatted statement, which is right formatted without any regard to the size, NITARP participant. Okay. You can also loop over floating point values, and the xval would take in turn, each one of these values. Okay. Any question on the for loop? That's the most common loop that we'll use in Python. The while loops are used when you don't have a specific range of values, okay, but you have a target. So while a certain condition is met, the loop is repeated, and then the condition, when it stops meeting the requirement, the loop is broken. So you can think of it as a hybrid if, then, and for loop. Okay. So the argument is kind of like what you just apply to the if statement, but the actual execution is more like a for loop. Here's one example. Again, this is just a very simple example. I start I with 10.3, and I'm going to increment it by a certain number for whatever reasons I thought was important to do that. But I have a target that once it achieves the target, it stops. And it tells me how many repetitions of incrementing I did to reach that target. Okay, so I set it up with saying while, and then I is less than target, colon, increment I, and then also count how many times, which loop number you're in, and then finally print it. Okay. There's one bit of warning with the while loops. If this condition is never satisfied for whatever reason, then the loop would repeat forever. Okay, and so while loops are not my favorite, but they do have their uses. And if you ever end up in a situation where you started executing your program and it looked like it would never end, you may have to kill it because you may be stuck in a while loop, and that's where I would go and check. Okay, any question on the while loop? Okay, so the best way to do this is I've I've assigned this as an exercise, is to actually write the code that will implement this flowchart into Python. And I think once you do that, you'll have a better appreciation of how this works, and you can compare it to the maximum function that we have either in NumPy, and see if you implemented it correctly. Okay, any questions? No? Okay. Then let's briefly touch on input, and then I will end here. We can then pick up more about input and output and maybe more nested and complicated if-then blocks next week after you've had a chance to try out the exercises. But before I get into that, I do want to emphasize that, besides looking at code, documentation, and listening to my excellent tutorials, the best way to learn programming is by picking up a programming task, and try and code it. Okay? It's practice, 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 which is what everyone always tells you. You want to get better at anything. I sent out an email. It would be highly recommended if you went and tried out some of these codes or picked up any problem that is of interest to you, and then I've given you some suggestions, and try and work this out during these lectures, doing these tutorials, and I can work with you so that hopefully by the time you get to the last tutorial, maybe you've written the code that solves whatever problem you were interested in. Okay. So I'm just going to take the time here now to emphasize that. You can send me email, you can send, or just send it to the group, or you can bring it up now or in one of these subsequent tutorials what you're interested in solving. And we can go through them online. Any questions on that? Okay, so let's briefly talk about files. I won't spend too much on it. I'm just going to introduce the concept. There's no exercises this time that would utilize them, but you're welcome to play around on your own. So we're not going to talk about binary files just yet. Maybe in the last lecture, we'll talk about the fixed binary files, which are common astronomy binary files. And ASCII files are usually tables or strings or numbers or something that you want to use. That's used. That's the more, what I would think is the more common use case for the type of things that you guys are trying to do. Here's the very basic code in how to connect to a file within Python and manipulate it. Okay, so you start off by telling that the file has a name and its location. So this is the full path name of the file, and I call it a file because, again, I could have called it anything I wanted to. Python doesn't care, but I'm writing this for me, and if I say file equals that, I will associate it in my head that this is pointing to a file and not anything else. You can just say A equals that string. It's just as valid, but A, you might think of it as a number, file name, name of my file, input file. Those sort of variable names will force you to associate the name with the file itself. Okay, but nothing's happened. You've just set a string variable to a certain value. So far, we haven't touched anything. We haven't done anything at all. When you want to actually have Python open the file, you would use the command open. Okay, you set that equal to another variable. In this case, it's OU. You could call it anything you want, but that variable is now your handle. an access point to the file itself. So you open the file, okay? You can read a line from it, and then you can close it, and then you can print that line. Okay, that's the very basic thing you can do with a file. Of course, there's lots and lots of things you can do, but the open and the close are the two most important. Okay, and once Python encounters those, it knows that it's dealing with objects that are stored on disk. Let me explain what the rest of the arguments are. Where do I explain? Okay, yeah. So if we go through this one by one, then you can see that the first thing that you did is just setting a string variable. Nothing fancy here at all. You can set as many as you like. And you can also use string concatenation shorthands to construct the longer names, which may include the directory and then the name of the file. Okay? And then there's the call to the open. And within that, of course, you want to give it the name of the file, however you store it. But then you also want to tell it how you want to manipulate it. The R, in this case, the second R that you saw, that was just for reading. Okay. So if you tried to write to this file, it wouldn't work because Python opened it as a read-only file. And that's important because you don't want to accidentally clobber your data. So if all you want to do is take that data from it, manipulate it, and maybe write it out to a different file, then you would always want to open it as an R. This is your precaution. Of course, if you want to open a file and write to it, you would use W instead of the R in place of R up here. A third option is A, which is to append. So you can write to it, but it preserves whatever came before it into the file. Okay. Once you open the file, you've got access to it through whatever variable you've named it until you explicitly close it. There are limits. I don't think that you guys will hit those on how many files you can have open at any given time in the Python session. That limit is pretty large. I think it's like 100 files. So you do want to close it. You don't want to just leave these things dangling and open. Okay. Then there's the next line was actually starts with line equals my file handle and then read line. Okay. So read line will just load up the next line. You can do a lot of things with that. So if your line, for example, was a string of numbers that you read the first row of a column of a set of columns of data, then it would read it in as a string, and then you can split it. And in this case, when you issue the split command, it would split it according to whatever instructions you gave it. If it's a comma-separated one, then inside the split, you would give it a comma, and it knows that it's a comma-separated split, just like the line above. Okay. Again, I'm just introducing you to what we do with files, and we will actually work on that more next week. Okay. And I'll leave the complete example for you to ponder and look at. It uses all of the concepts that I've introduced so far and that you have learned so far and defining, maybe a couple of new ones. Okay. And we'll do NumPy next week. Any questions about file open or closing? Okay. Any questions in general, in particular? Okay, well, then let me end this session, and we will start again next week. The last thing, again, is my emphasis to you that you should try more of these exercises, try writing code on your own. The more you try, the better you will understand the concepts. Programming is one thing where you really can only learn best by doing. Okay, well, thanks for coming and participating, and I'll see you guys again next week. Okay.
Okay, thank you.
Bye.
Thank you.
Thank you.